Part C of number 42, how far does the particle travel in the interval from 3 to 6? And this is the velocity function of the particle. We begin by setting up the expression that represents the distance traveled by the particle, which is the integral from 3 to 6 of the velocity dt. So how far does the particle travel? That refers to displacement of the particle, which is that. And then we go ahead and we type that into a calculator. Remember, this is our function. This is our function right here. We're typing that into the calculator. So I would store it under y1. So go to y1, clear that, clear that. Let's type that into y1. ln of x plus 3 minus e ln of x plus 3 minus e raised to the x over 2, take away 1, followed by mod times cosine of x, and that's it. So that's the function. And so leave the screen, second mode. We're going to go ahead and evaluate this. So math 9, go from 3 to 6 of that function, which is y bar, choose y1, dx from 3 to 6, and that should give us 4.201. Okay, so 4.201 meters. So the particle from time 3 to time 6 traveled 4.201 meters. Now part D asks, at what time in the interval is the speed of the particle decreasing? The speed of the particle decreasing, okay? So speed is decreasing when the velocity function, when the derivative of the velocity function is negative. Okay. So the speed is decreasing when acceleration is negative, which makes sense, right? So what we have to do is we have to graph the derivative and see where it is negative, because because when acceleration is negative, that means speed is decreasing. So go back to your y. Okay. Now y1 stands for the velocity function, and we're graphing the derivative, right? So to graph the derivative of that, you go math 8, and you're graphing the derivative of y1. So we need y1 to go in there. So bars, y bar, enter, enter. You get y1 in there. Now to graph the derivative, the x should all equal to x, and that's how you graph the derivative. Make sure your window is from 0 to 8, and then go back to your y. Now you don't want to graph that, so go ahead and unhighlight that by hitting enter. You only want to highlight this because that's the one you want to graph. So let's go ahead and graph. And by graphing, we can kind of see where the speed is decreasing right there. So the speed is decreasing from at that point, and then hopefully somewhere over here. It does take some time for the calculator to graph the function, so we have to wait and wait until it's done. So there it is. So now we need to find the intersection, the zeros for that point, and that tells us where the velocity is decreasing. So we will need to wait until that circle is done. It takes time to graph this function. Okay, so this is from 0 to 8. It is still graphing. So and now it's done. So we want to know what that point is. So 7, calculate zeros. I guess let's calculate that first. That's one of the zeros. So that would be at 3.667. Okay, 3.667. Keep that number there. Let's calculate this first one. So left bound. left bound, followed by the right bound, enter. So the speed is decreasing from 0.621, so 0.621 to 3.66, I think it was 3.667 or something like that. But anyway, we can always calculate it again. Okay, so second, calculate. This is our left bound, okay. And sorry, I think that's going to give us an error. Okay, so second, calculate. Try to go fast, but you can't really go fast. Left bound, right bound, hit enter. 3.667. Okay, so 3.667, that's what it was. And then it's also decreasing from here to 8, so we need to go ahead and figure out what that is. Okay, so left bound is at left bound. This is my left bound, so move it as close to that as possible. Uh-oh, it's still going. It is still, it went past right there, right there. Okay, left bound, right bound, take a guess. And therefore it's going to also be decreasing at 6.782 8, because 8 is the ending time. And there you go, that's why the speed is decreasing.